In this video, we're going to be talking about area and perimeter in 3rd grade. And the TEKS that we're going to be working on are 3.7b, 3.6c, 3.6d, and 3.6e. So students in 3rd grade need to determine the perimeter of a polygon or a missing length when given perimeter and remaining side lengths in problems. And the important thing to remember about perimeter is it doesn't just have to be squares and rectangles. It can be those irregular polygons that we're finding the perimeter of. 3.6c, we're going to determine the area of rectangles with whole number side lengths in problems using multiplication related to the number of rows times the number of unit squares in each column. So when we're working with area and perimeter, we are talking about squares and rectangles only. And we're actually not going to be using the formula or teaching students the formula for area this year, but we are going to be talking to them about how, when I look at area of rectangles and squares, I can relate it to arrays, right? And what we already know about arrays. Then we have to decompose composite figures formed by two rectangles into non-overlapping rectangles to determine the area of the original figure. And then with that, then we're going to be decomposing two congruent two-dimensional figures into parts with equal areas and express the area of each part as a unit fraction of the whole, and recognize that equal shares of identical wholes do not need to have the same area. All right, so as far as previous knowledge for area and perimeter, for perimeter, there is none. No previous grade has talked to students about perimeter. In 2nd grade, they are given a shape. For instance, let's use the back of this geoboard. They are given a shape, a square or a rectangle, and students have to use square objects and place them right on top and cover this object all the way up. And then they count how many squares are on top. Okay, so we're going to pretend that I did all that. So what they do is they actually cover the entire shape with as many squares as they can. They'll even come up here and cover this, right? And they'll say that it's about 1, 2, 3, 4, 5, 6, and then however many I have this way, it should be 6, right? So it's about 36 square inches, okay? That's the area, or 36, they're not going to say square inches, they're going to say that's 36 tiles is the area of that shape. So that is all they do in 2nd grade. It is a very concrete look at area, a very basic introduction to area. All right, so let's talk about perimeter first in 3rd grade. I'm going to start off very basic with perimeter. I may have students create a rectangle with 8 tiles, just like mine here. Okay. And we're going to talk about what is the perimeter of the shape. Okay, and to help students think about perimeter and area, something I always had my kids draw. There are many other ways you can do this, but I always had them draw like a little window pane. And we put the word perimeter around it so they could see that this is the rim, right? So I'm looking for the outside of the shape, and then we put area on the inside. And so students knew that when I was thinking about area, I was looking for the inside of the shape, right? I was measuring the inside of the shape. All right, so when I'm starting out with perimeter, I'm going to want to start out concretely. I can start out using color tiles like this, and we can talk to students about each. The perimeter is the outside, so this is 1, this is 2, this is 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this rectangle has a perimeter of 12. And then we're going to call it, you can call it tiles right now. I would get them to start thinking about this as 1 inch. So 12 inches, right? So then I can say, okay, so what about this rectangle? Does it also have a perimeter of 12 inches? Right? And so we're going to figure that out and say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 inches. And you're going to ask students why. Why does this rectangle have much larger perimeter than this rectangle? And so then you can start playing with tiles. You can ask students to create the largest perimeter of a shape using 12 tiles, using 10 tiles, create the smallest perimeter with those tiles. And so it really is just getting students the option and ability to play with perimeter. Sometimes teachers like to use Cheez-Its too, since food always gets kids going. They'll use Cheez-Its as their color tiles for lesson. Then once we've kind of worked with separate color tiles and they see each one is an inch, we can then move into something like this where we have them create rectangles and they find the perimeter of the rectangles. Let's see. So we could once again do this, talk about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So this has a perimeter of 18. And then we can talk about, well, what about this? That has a perimeter of 18. What does this have a perimeter as, or of? Because now we have an irregular polygon. And so we're going to talk to them about doing the same thing. This side has 1, 2, 3, 4, 5 inches, or 5 pegs, right, or spaces. 1. This one's kind of open. I meant to do this. There you go, because we don't want any angles. We're doing all where it's on the straight edge. So 1, 2, 1, 2, 3, 4, 5, 6, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, and then we can add them all up. So it gets students working with those unusual shapes. We can also do perimeter with Cuisenaire rods. So we can give students and say, what is the perimeter of 3 green rods? And students can put those 3 green rods down, trace it, because I could do it like this and trace them, and then count the numbers, and then I can find the perimeter. I can also do the perimeter with base 10 blocks by give students a shape. I can then have them use base 10 blocks to find the perimeter. So, I can do this. And then, I can do this. Let me do this instead. That'll be much easier. So they can figure out how they can use base 10 blocks to cover the shape. And then, of course, they're going to fill it all in with their units and so forth. Then they can count how many squares on each for the perimeter. Okay. All right, so that's a little bit with perimeter. We're going to look at a perimeter problem in a minute. Area, we can do basically the exact same things. For area, I can show them, have them create that same rectangle that we did. and we can talk about the area of this is 8 square inches. And then I can say, okay, well, when we did the perimeter, it changed, but what about when we do area? Does it still have an area of 8 square inches? Yes, it does, right? So we can talk about, really the shape doesn't matter if it has the same area, right? I can change its shape, but if it's made up of the same number of square inches or square centimeters or whatever, the area is not going to change. Then from there, once again, I can go back to a geoboard and I can ask students to create me a shape with an area of, I don't know. I can give them this shape and ask them what the area is. They can count the squares, or you can ask them to make a shape that is a certain area. Okay, because remember, you're only dealing with squares and rectangles at this point. Okay, and as you're working with these, it's very easy for kids to look at it, and you can ask them, so what is the length of the shape? What is the width of the shape? I can count the individual squares, but what is another way that I could find the area of this without having to count all the individual squares? What does this look like to you? What have we done that this looks like to you? And hopefully they'll relate it back to an array. It looks like an array. So this is 1, 2, 3, 4 rows. 1, 2, 3, 4, 5 columns. So if I want to know how many squares there is, I could do 4 times 5. And if they don't believe you, you can actually count them afterwards. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, so it's a good way for you to introduce that. Then when you get into composite shapes, because that's one of your TEKS, say I have this shape and I want to know the area of it, you can talk to students about how can I break this rectangle up into 2 different rectangles. Well, some students may break this rectangle up like this, and the geoboard's a great way to kind of show them this concretely. Or a student could break it up, this shape up like this. Either one is correct, right? So then you talk about finding the area of this first rectangle, and then you talk about finding the area of the second rectangle and adding those 2 areas up together. Okay? So that is how you can do it concretely. Another activity you can do, once again, is with our centimeter grid paper. You could give your kids 2 dice, have them roll the dice, have them find the Cuisenaire rod, which matches the length of one of the dice, and then you put that many Cuisenaire rods on your paper, trace around it, and then you either count the squares or you use the arrays, what you know of arrays, to find the area of that space. Okay? Once again, you can also use this type of activity as well, where you give them, now this shape would be a little hard for them, I think, in 3rd grade, because unless you're doing it concrete. If you're doing it concrete and it's a beginning activity where they just put all the blocks in and then they count them up to find the area, you could do that with this type of shape, but then when you get to multiplication or breaking them up, it's too much for students to do. Remember, they're only usually going to have to break up a shape into 2 different rectangles. Alright, so let's look at some problems with, oh, I forgot to mention this. One of the activities you're going to want to do with students is you're going to want them just to do an activity where they sort. Is the problem asking about the perimeter, or is it asking about the area? Okay? Because that's really hard for students to determine. Alright? So, for instance, if I gave this problem to students, the Smiths are putting a new wood floor in their living room. What do they need to know? If I'm looking for a floor, that definitely is going to be area. If Mark wants to build seats around the edges of the sandbox, what does he need to know? That is, of course, going to be the perimeter. So I think doing a sorting activity with students is really, really important. See, these problems didn't have numbers that they had to worry about. It was just about the situations they might see. All right, I wanted to show you how these could be asked on STAR. These are problems from 2 years ago on STAR. First of all, this is a perimeter problem. And for this problem, students have to find the perimeter of each one of the shapes to see if if they have a perimeter of 54 millimeters. So on this, if I'm finding perimeter, it's the outside of the figure. Of course, I would just have to add all the sides of each one up, find that perimeter, and then I would have to find all the ones that have a perimeter of 54 millimeters. Okay. Now with perimeter, I think most of the time you're going to have a picture because it may be a missing side. And with a missing side, once again, you add up all the sides you know. You subtract it from the total perimeter of the shape. If it doesn't have a picture, I encourage you to have students draw a picture, especially with area. All right, so here's another one. And this is one that's going back to thinking of area like an array because it's given you the length and the width, and then they want to know the area of the rectangle. Okay, so for this one, students would count 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, and then they can find the area of this shape, which is 28 square centimeters. Okay, and then here's the last one. This one has to do with separating a rectangle into two non-overlapping rectangles. And on this one, they've already done the separation for you. And they gave you the length and the width already broken up into your square foots for you. So they just have to find the area of this shape and add it to the area of this shape. All right, I hope this has been informative about area and perimeter. If you have any questions, as always, please email me or call me and we will answer them, and we will see you next time.